Question 8 says solve each equation, and there are two of them. There's a part A and a part B down below for x, and to include a check for your solution. So in the first equation, I can see that I've got fractions, and my preferred method for proceeding is to not deal with those fractions. So I'm going to multiply both sides of this equation by a value that will eliminate or bust up all these fractions. And you can see I've got a denominator with a 3, and then over here I've got a factor of 2 and a factor of x. So if I multiply both sides of this equation by 6 times x, it will effectively destroy all of those fractions and just give me only numerators on both the left and the right hand side. So what I'm doing here is I'm pushing into this equation a factor of 6x to each term on both sides, the left and the right hand side. The left hand side has two terms, the right hand side has one term, but all of those terms are going to get a factor of 6 times x in the numerator. So if I rewrite this, you can see I'm going to have a 15 and then times 6x over 2x, and then plus 7 times 6 times x all over a 3, and that will equal 8 times 6 times x over a 3. So to be real clear here, what's happened is every single one of these numerators received a factor of 6x, and then 6 times x. So now as I go through and I simplify these, right, because in the first case there I've got 6 times x in the numerator and a 2 times x in the denominator, that forms some giant ones, and this literally ends up being just, what is it, just 3 times 15 or 45. If you'd like to see that in slow motion, that's over here. So this numerator is 15, and then times a 2 times a 3 times an x, and the denominator was a 2 times an x. You can see when I combine the factor of 2 in both the numerator and denominator, that makes 1, and then the factor of x in both the numerator and denominator makes 1 as well. So we're left with just 3 times 15 times 3, which is 45. Same thing happens with the next term. You can see there's a 6, which is 2 times 3 x, so that's going to end up being 14 times x. And again, slow motion, you can look at that. That's 6 is it's a 2 times a 3 times an x, and when that's over 3, that's why I end up with just 2 times x. 2 times 7 is 14, so 14x. And then I won't do the same thing on the right hand side. Just 6 divided by 3 is 2. That's 2x times 8, which is 16x. I'm going to take away 14x from each side, so I get that 45 equals 2x, and if I divide both sides of that by 2, I get that x is going to be 45 halves, and there's no common factors there. That's a fine answer. You can turn it into a decimal. What is it? It's 22.5. That's fine as well. But I want to include a check for this. So what I'm going to do is I'm going to take my answer, plug it in to this particular denominator here, and verify that when I take that and I add 7/3, I really do get 8/3. So I'm going to just start by turning on my calculator, and then I'm going to enter 15, not 11. 15. Actually, you know what? I'm going to use the fraction key because this has got the new ROM on it. So I'll do the fraction key. In my numerator, I've got a 15. In my denominator, I've got 2. And then I'm going to multiply that times. I'm going to bring up another fraction inside of the denominator. That's cool. Inside of there, I'm going to just put 45 over 2. Actually, 45 halves times 2 is going to just equal 45. But I'll leave it here anyways. And then I'm going to add to that plus, and then I'll just grab my fraction key again, 7/3. So I don't typically do this all the way, but I do like how I can see that visually this fits exactly what I've got on the paper here, right? So 15 over 2 times x, and you can see x is 45 halves, and then plus 7/3. Now when I press enter, right, you can see that it makes it exactly 8/3. So that's perfect confirmation that the left hand side is the same as the right hand side. So the moment we know what x is, 45 halves, we can say, hey, that's the value of x that will make this truly equal, right? They're really equal to each other at that point. So that's our solution, and that's the check for it. Let's go ahead and look at the last one here. So our textbook talks about something called looking inside, and if we just consider this for a minute, inside the radical symbol here, right, we've got this 3x plus 12. I happen to know, some basic squaring facts, and I know that the square root of 49 is 7. So if you think about this big picture, I'm taking the square root of something, and I am getting an answer of 7. Well, the thing that I take the square root of in order to get an answer of 7 is 49. So I'm just going to say this thing inside 3x plus 12 has to be the number 49, because when I take the square root of that, 49, it would produce 7 for me. So this is the approach that our textbook outlines, and I think I'm pretty comfortable with this. So let's go ahead and take and subtract 12 from the 49. So I've got 49, we're subtracting 12, that's going to be 7, and that will be 3. So I've got 3x plus, I'm sorry, will equal 39, or 37 rather. And then I'm just going to divide by 3. So x should be 37 thirds. Now, I don't think I'll use my calculator this time, but if I take 37 thirds, right, and I multiply it by the number 3, because it says 3 times x. So 37 thirds times 3, that's just 37. And if I add 12 to that, that's 49. And if I take the square root of that, right, I do indeed get 7. So the value of x that makes both sides of this 7 is 37 thirds. And that's a fabulous answer. You don't have to convert that to a decimal.